Following up on the previous video and without wasting any time, again, go to Mesh, Modify and select Plane Cut. Choose the plane that passes through the symmetry axis of the piece. This is the plane, and we confirm. Now we have half of the piece. I'm going to do something that might be necessary, okay? There's the option to use remesh or reduce. I usually use reduce, which reduces the number of elements. However, remesh essentially transforms the mesh. Take a look at the current mesh. It has areas with different element sizes. You can see there are slightly larger and smaller elements. I'll apply this command. Using an adaptive mesh and keeping the default values, I'll leave the Preserve Sharp Edges option enabled. Let's preview and analyze the result. As you can see, the result wasn't very different. However, you can always tweak these settings. And as you do, you'll notice changes in the mesh. My comment here is that I don't fully understand what's happening. I know I can adjust the mesh density, but understanding the dimensional and geometric implications is challenging. Let's see. Did you notice that the density increased significantly? This was the initial state. Now, I'll use the tool I usually rely on, Reduce, and apply the tolerance option. I'll tell the software I want a tolerance of 0.1. What does this mean? It means that dimensionally and geometrically, the maximum error I'll allow when reducing the number of elements is 0.1 millimeters. Let's preview it. You can see a significant reduction in elements. However, in this case, I won't use either tool. Why? Because I want to demonstrate other things while keeping the original high-density mesh intact. Next, we move on to the Create Form tool. We'll start with the Face command. This command, combined with the Object Snap option, allows you to leverage the points on the mesh of our model. Notice how it snaps to the vertices of these small triangles that form the mesh. Can you see it? As you create these planes aligned with the original geometry, the mesh will soon be translated into a T-spline. Continuing the process and trying to maintain a certain uniformity, you're essentially tracing the shape. Once again, note how the tool translates the original shape. It may appear highly polygonal, but it's not. We're working with a T-spline. When I confirm with OK, the model will smooth out. At the moment, we're viewing the model, or rather the tool, in box mode, which is the best way to achieve optimal results. I'll click OK to show you the result. And here it is. You can clearly see that it's trying to translate the object beneath, and the process progresses incrementally. Now, it might make sense to reduce the opacity here to about 50%, for example, so I can better see what I'm doing. Don't worry about this alert, it just indicates that the model is open. Let's move on. I need to activate Object Snap. I'm not going to model the entire piece because that would take too much time. This way, you get an idea of how it's done. If I tried to complete the entire piece, I wouldn't have the chance to show you other options for creating a 3D model from this mesh, as well as other techniques. The main question here, which often requires attention and adjustments, is what size should the polygons be? Should they be larger or smaller? This depends on the complexity of the area you're working on. If it's a very intricate area, it's best to use smaller polygons. For less intricate areas, larger polygons are fine. I'll consider this done for now and will accept it as is. As you can see, we've quickly increased the processed area. Now, there are some areas that are obviously higher, while others are lower. In this case, there's a margin of error we need to accept, as this is not an exact process. Even so, it's possible to keep refining to achieve a satisfactory result. Notice that this point it selected might have come from a part of the mesh that's no longer relevant. The ridging you see here is evidence of that. However, the result we're getting is close to reality, especially after completing the entire contour. There are some issues here that might raise questions. If not, let's proceed. I'll switch back to box mode. To do this, I can use the Alt key, and I'll need to figure out a way to close off this entire area somehow. The polygons you create here should ideally have 4 sides, resembling rectangles or, better yet, squares. Following this guideline will make things much easier. However, it can be more complicated than it seems. Let me show you. I'll reactivate Object Snap. Place this point here, then this one and this one, which goes roughly in that direction, and continue the process. Even though it's far from perfect, it's good enough to demonstrate the situation. I'll refine it a bit more. Move this one slightly downward like so. Now, where should this connect? And this one, where should it link? Here. But this will create a triangle. And yes, that's what happens. These are the kinds of challenges related to what I call mesh topology, which requires some attention. For example, when you create 1, 2, 3, 4 polygons here, you'll likely want an equivalent number on the other side. Sometimes this happens, requiring you to go back a bit. Let's continue, making adjustments until we achieve a satisfactory result. This step is often time-consuming. Sometimes you have to go back quite a bit before you get a result you're happy with, which can be frustrating for those not used to it. Notice that even though it's not a rectangle, we have 4 sides here. This means we can close this off, especially since I can adjust this vertex to better represent the part, and that's what I'll do. So far, I'll select this, and now with another tool from Modify, I'll adjust the element. You should aim to ensure that the topology remains consistent with what I mentioned earlier. Avoid adding more geometry, because if you do, you'll need to add it to the rest of the piece. While there's no inherent problem with this, it will increase the model's complexity. With a high number of vertices, you'll eventually need to use more advanced tools like soft selection, which moves elements within an influence area that dissipates. And here's this part. Let's accept it and even hide it, at least for now. Notice that it is now necessary to join these 2 sides, but the topology is not consistent since we don't have the same number of sections on both sides to connect. In this case, I will use the Insert Edge command, which will allow me to create a subdivision of the face closest to the symmetry plane. This will create the conditions needed to maintain the topology based on 4-sided polygons. In this case, I'll instruct the software to place the division exactly in the middle of the faces immediately below. Therefore, the value to input is -0.5, which means it's at 50% of the length. Now that the conditions have been set, we can use the bridge command to connect the 2 edges. However, as previously mentioned, we could also use the same command we've been using to construct all the other faces. The result will look like this. Notice that the model is now smooth, and the surface appears accurate and consistent with the original model. Now it's a matter of continuing. I'm not going to do more on this side. Instead, I'll show another situation. There will come a time when I'll want the symmetrical part, and that will be when I finish this area. At that point, I'll want the area on the other side, and for that, I'll use a command similar to mirror. But before moving on to that, I'd say I still need to do a bit more on this side. Let's use Alt+1 again to view the polygons in box mode and try to trace some of this edge running along the top, at least up to the front, so you can understand the importance of the face command. I'll activate the top view and rotate this to better see what we're trying to do. Then activate Object Snap again. I'd say I'm roughly aligned with the top. It's important to maintain some consistency with what's already been done, as well as keeping this edge thickness relatively uniform along its length. I definitely don't want to add more geometry, because if you do, you'll also need to adjust the adjacent surfaces. It's not that it's a problem, but it will create more work. And here we have the edge. Let's accept it and, for now, hide it. Note that we're currently working with two bodies, two T-splines. Next, I will use the bridge command multiple times. Why? Because we're going to create bridges from one side to the other. But you could just as well use the face command, which, in this case, would likely be a more accurate option. I don't know if you've noticed in the first operation I performed, but this immediately converted the T-spline into a single body, which is great. However, let's explore the bridge command. By pressing B, you can invoke this command. I have a shortcut for this on my space mouse. The downside of bridge is the need to keep repeating the operation. Notice that it doesn't save the previous result, which might make it a bit more time consuming. Yes, there's just one left to finish. Sometimes it seems to freeze a little, probably uploading to the cloud. So, once again, you often need to switch between smooth and less smooth modes. You may have noticed a small change, but that change might not align with expectations. Why? Well, that's because T-splines inherently smooth out the model. This happens because smoothing is applied uniformly across all elements. I can break this smoothing effect by using a command also available here under Modify. It's called crease. I'll activate it, select here twice, and it will propagate the effect to the other end. What will happen? It will stop being smooth and take on a more defined look. Now let's see, and here it is. You can clearly see the result. To try and replicate what's underneath, we can of course do this and say, maybe this could be slightly higher or lower. That's fine. You can use the Move tool here and even switch to a coordinate system better suited for this context. I clicked there, but that's not where I wanted. I need the base coordinate system, and you can tweak this to achieve the desired effect. Be mindful. If you pull this backward, remember that it will also move back here. It may look fine in one place, but wrong in another. In other words, it won't turn out as expected. To fix this situation, you might consider using the scale command. However, I don't think it will work in this case, but I'll demonstrate. I'll switch back to selection mode to try and understand if using scale is viable. No, it's not viable. Let's use the scale option at the corner of the gizmo, which will adjust the scale in the plane. Both scenarios essentially involve the scale command. Sometimes this tool solves the issue, but not in this case, given the three-dimensional nature of this part of the piece. Here, the only alternative is vertex by vertex manipulation. It's not complicated, but more labor-intensive. I prefer performing these operations when I know I could achieve the same result much more easily in another workspace, such as the surface modeling environment using the sweep or even the loft command. In the meantime, we've spent quite some time on this issue, so let's move forward. Now, I want to obtain the other half. In this case, we can hide this, at least for now. Let's assume this part is good enough. Let's choose symmetry, followed by mirror duplicate. In this case, it must be mirror duplicate. I'll select the T-spline we just created and the symmetry plane located down here. There it is. And here we have the result. Sometimes, as you can see, some areas are welded while others are not. That's why we'll use the welding tool in this case to weld vertices. Activating the weld tool from the Modify menu and selecting Weld Vertices, shortcut key W, will then weld the different vertices that are separated. Since we're welding along the symmetry plane, we don't need to be overly cautious with the options, as the points on each side will meet in the middle. However, in a normal situation, this wouldn't happen, which is why an option is available for this. In this case, I'm trying to grab that vertex. Yes, it worked. Let's zoom in a little more. This one seems to be done, and so are these. Notice that we now have a green line, indicating that the objects are joined. Now we have the complete object, though it's still unfinished. Let's imagine this was the panel we wanted. We'd now have the object in its entirety. For those using more traditional tools, think about how much time it would take to achieve this using surface created from 2D reference images. Let's finish the command. The T-spline created with this command has just been converted into a surface. Yes, now it's a surface, which means we've entered another domain. The domain of surfaces equipped with extremely powerful tools. Once you have a surface, it's quite easy to turn it into a solid. One way to do this is by using the Thicken command. This command is available here, and if you now assign a thickness to this object, let's say 1mm, it will effectively generate that thickness. Notice that it only selected part of the object, likely because of this sharp edge. Ideally, it should have selected more, but let's try again. I've already noticed that 1mm is probably too much for this piece. Let's use 0.5mm, and now we have the entire thickness applied, all at 0.5mm. But I don't want to proceed with this just yet. What I want to address first is this element here, where I used the crease command to create a sharp edge. However, the original model doesn't have a sharp edge. It features a fillet, which is currently not visible, but it's present. Here, you can see the fillet. This would be the perfect moment to create the fillet. How? By using the fillet command, as long as the surfaces are completely joined, which they are since I only have one surface here, you can use the fillet command without any issues. The command is available here under the surface tools. Select the entire contour and apply the command. Let's set the fillet to 3mm, confirm it, and now finally let's apply the Thicken command. Let's consider a thickness of 0.5mm, and here we have the thickness applied with the fillet seamlessly created on both sides. In the next video we'll take a similar approach, also using T-splines, but in a way that's less universal, more specifically tailored to this case. If you found this video useful, don't forget to give it a like or even follow the channel. I know it's not something I usually ask for, but as you can see, the channel needs to grow to make it worthwhile to keep producing this kind of content. Thank you, and see you soon.